Dear students, welcome to all. Today we are going to study the working of transformerless class B push-pull amplifier, also called the complementary symmetry amplifier. This is one of the most important power amplifier circuit because it is widely used in audio amplifier, televisions, radio, mobile phone, Bluetooth speakers and home theater system. First, one question: can a simple transistor amplify both the positive and negative ops of an AC input signals efficiently? The answer is no. A single class B transistor conducts only for 180 degree of the input signal. Therefore, it can amplify only one of cycle of the waveform. So, what should we do to amplify the complete AC signal? The solution is to use two complementary transistors. So one transistor amplifies the positive half cycle, the another transistor amplifies the negative half cycles. So when both outputs are combined, we obtain the complete output waveform. So this is why the circuit is called as push-pull amplifier. The circuit consists of one NPN transistor Q1, one PNP transistor Q2, biasing resistors R1, R2 and R3, coupling capacitor C1 and C2, load resistor or loudspeaker. Since no transformer is used here, so it is called as transformerless push-pull amplifier. So why it is complementary symmetry? So notice that one transistor is NPN and another is PNP. So these two transistors have similar electrical characteristics but opposite polarities. So hence they are called complementary transistors. The circuit is also symmetrical. That is why it is known as complementary symmetry amplifier. The working of the circuit is, suppose the input signal becomes positive. What happens? The base of the NPN transistor Q1 becomes positive with respect to its emitter. So therefore Q1 becomes forward bias, hence Q1 enters the active region and start conducting. At the same time, the PNP transistor Q2 becomes reverse bias. Therefore Q2 enters the cutoff region and remains off. So now current flows through Q1 to the load. As a result, only the positive half cycle appears across the output. So remember, positive input Q1 on, Q2 off, positive output half cycle. Case 2, negative half cycle of the input. The base of Q1 becomes negative, therefore Q1 becomes reverse biased, hence Q1 turns off. At the same time, the base of Q2 becomes negative with respect to its emitter. Since Q2 is a PNP transistor, this condition forward biases it. Therefore, Q2 enters the active region and start conducting. Current flow through Q2 and the load. This produces negative half cycle across the output. So remember, negative input Q1 off, Q2 on, negative output half cycle. During the positive half cycle and negative half cycle, Q1 and Q2 contacts respectively. Since each transistor amplifies one half of the waveform, their outputs combine to produce a complete sinusoidal output. Therefore, the amplifier reproduces the entire input waveform at the output with the increased power. So why it is called push-pull? There is a common question. During the positive, Q1 pushes current through the load. During the negative half cycle, Q2 pulls current through the load. Therefore, two transistors alternately push and pull the load current. Hence the same push-pull amplifier. So each transistor conducts for 180 degree of the input cycle. Therefore, this amplifier belongs to class B operation. The efficiency of this amplifier is maximum of 78.5%. regarding crossover distortion near the zero crossing, both transistor remains off for the very short interval. As a result, a small distortion appears in the output waveform. This is called crossover distortion. To reduce this problem, we use class AB push-pull amplifier. Advantages: high efficiency, no transformer required, compact size, less heat generation, low power loss, suitable for driving loudspeakers, good impedance matching due to emitter follower configuration. Then disadvantages: crossover distortion occurs, requires complementary matched transistors, biasing should be proper. Circuit becomes slightly more complex than a single transistor amplifier. So this type of amplifier circuits are used in audio power amplifier, Bluetooth speakers, mobile phones, television, audio stages, public address system, car audio system, home theater system, and radio receivers. Thank you.